Okay, so let's have a little bit of a question here. So now we're going to use our polling. So most of you should see some kind of poll now. I think it doesn't work if you're in the browser-based Zoom, but I'm not quite sure. So now we would like to achieve this transformation. What do we do? Here's the responses I got. So this thing is going to get bigger. So this is a scale. Um, we can check our answers by multiplying times the matrix. I don't know if I can annotate that well here, but suppose we consider the point 0, 0, 1, right? I'm going to consider this origin point, and I'm going to multiply it times this matrix, because what these matrices are meant for is taking a point, each of the vertices, right? Not just one. We're going to take each vertex in this shape, and we're going to multiply it. So let's consider the 0, 0 point with this 1 because homogeneous coordinates. We're going to do this multiply. And I'm going to write it on this side because this is a convention that we're typically using. And so if I do this multiply, I'm going to get this 0, 0 ends up at the position 2.1.851. We don't have to worry about the divide because we're still on 1. But that's going to mean that this point moved up. But that's not what actually happened in this case. So A can't be the answer. So we could do the same thing for each of these. So it turns out that B is actually the answer that we want here, which most of you found. But we can check whether our answer is the right one by just doing the multiply. Pick a point, 0, 0 is usually easy, and find out where does it go. We're going to have another case here. My mouse. Okay, so now, we're gonna share results, relaunch polling, continue. Did you get a fresh poll? Okay, so now, which answer is it? Okay, here's the responses I got. In this case, this is a translation. Our R has moved from its original position on the origin up into a new position. So that's a translation. So this matrix right here is a translation. This one is a scale. It's the one we saw previously. This one is a non-uniform scale. And this one is a rotation. I know you don't recognize all of these matrices yet. You will by the time you get done with the next assignment, very likely. And we could check whether things move to the right place by multiplying our point times each of these to see what's going on. Now you might ask, why did this axis move? Right? Why didn't we just draw the axis and only show the object move? There's a duality about, am I moving my coordinate system or am I moving my object? And it's sometimes convenient to think of moving the coordinate system, and it's sometimes convenient to think of the object. And I think that'll probably be confusing for a little while, but it's something that's done quite often in graphics to talk about it first one way and then the other.